Testing, testing. Testing, testing. All right, doing an audio check. Victoria, can you guys hear me okay? At this level anyway? I'm not talking at my full volume yet. Awesome. Thank you, Caitlin. Alrighty. Sorry for being 10 minutes late, but I'm ready to start. How are you guys feeling? Ready to start? Yes? Awesome. I got a lot of thumbs ups. That's awesome. Welcome. We got another lecture together, so that's going to be exciting, hopefully. I know that yesterday was a tough day. Generally, it is. I'm getting nods here at least. Victoria, I'm probably going to get some thumbs up from you that it was a bit of a tough day. In terms of like, it's a pretty heavy day. There's just a lot to do, right? There's a lot to learn. There's really long assignments. Because it's like kind of some of the meat of Tiny App, right? But what do you notice about today in terms of what you see in Compass? A little bit lighter, right? The opposite thing? That's intentional. I did that intentionally. It's not a mistake. The reason for that is because we want to get you to a point where by the end of today, you're feeling comfortable at, if not early today, then later today, getting comfortable with getting closer to submitting Tiny App and calling it complete in terms of what the functional requirements are, right? Hopefully it's been an interesting learning experience. Keep in mind, it's your first project. It's your first time dealing with, you've learned a little bit of asynchronous logic last week, right? With like client-side TCP and HTTP and things like that. But keep in mind, this is your first time dealing with like, what does a web server look like, for many of you anyway, right? And all the kind of asynchronous nature of everything. So there's that. There's also the fact that it's your first time dealing with a project at Lighthouse. So how to pace yourself, how to prioritize your learning versus getting stuff done. Those things take a little bit of time. How much help to ask for? Are you guys feeling like you're still getting calibrated on some of that each week? Yeah? So that's good. What are we going to talk about today? Well, because we're at the tail end of Tiny App, and at least the tail end of kind of the learning outcomes of this week, right? Because Fridays, as you know, are quite different, right? In our new program, Fridays tend to be what we call Fundamental Fridays. Most often there's tests, and then more importantly, there's just other concepts that are not about the projects. It's more about the fundamentals of programming, computer science, things like that, right? And this week will be no different in that respect. So really then, today being Thursday is like kind of the final day of Tiny App, right? Which you guys are going, probably some of you are internally going, holy shit, like I'm still catching up to yesterday. Today's the final day. Again, the content for Tiny App today is light, right? So it's really about catching up. It's most students are catching up to yesterday's work today. but we wanted to kind of light that fire yesterday instead of today, right? Because just the nature of how we work and how we prioritize things, it's crunch mode near the end, and I wanted that crunch mode a little bit earlier, right? That's why I kept that yesterday quite heavy, right? So what is today about then? Well, today, if you noticed in Compass, it's less about TinyApp, right? It's more about kind of web development in general, Express or other frameworks that we could look at. Because it's our first time doing that, so what is some of the context? Why are we learning this? Is this stuff really actually used? And how is it actually used? Because as you might imagine or assume, the way TinyApp is built right now is still from a learning perspective. And therefore, we're writing code that's not exactly like how you would write code in the real world. Can somebody think of examples of how we're doing things in TinyApp that probably, could be a guess, that in your guess, isn't really how apps are built in the real world? And then I'll also ask the question of, can you think of things that we are doing in TinyApp that are very real world? So feel free to give either one, but I'd like to start with, if we can, what are some of the things we're doing in TinyApp or not doing in TinyApp that need to be done in the real world? Oh, something from Victoria. Thank you for keeping an eye on that. Yes, Caitlin nailed one of the biggest ones, which is lack of a database. When I was mentoring some of you yesterday, I used the word database, but I always used air quotes, because a database is just a storage of data, right? So, I mean, our object called users or object called URLs is a database. It's just not a real world database. Why is it not a real world database? Because it's stored on the server. The database is stored on the server. Can you be more precise? Yeah, you lose your database quite frequently, actually. So it's not really anything we'd want to deploy into the cloud for people to use. Because anytime when does it get cleared? Sometimes when you don't want to clear it. Whenever you restart the server. Now, you're using NodeMon or are you using Node? You're using NodeMon. And one of the things I actually wrote down for myself to talk about, because I noticed this yesterday with some students as I was mentoring, was NodeMon's great from a convenience perspective, but it restarts the server even when we just hit save on a JavaScript file. Maybe not on an EJS file, but on a JavaScript file. Agreed? And anytime the server restarts, because our object is in memory, we're starting up the app again. That object's going to start up with whatever if it's empty, it's going to start up empty. If it's got only 2 entries, it's going to start up with just those 2 entries. And so our database not only restarts when we want it to, sometimes it just restarts because we hit save because of NodeMon. And I noticed some students were getting tripped up on that, so I wanted to make sure that I speak to that a little bit. But yeah, that's definitely one of the things that is not real world in terms of how we're building TinyApp. What else? Anything else? Yep. Remember your name? Fabio? Yeah, absolutely. I'm going to write this stuff down. TinyApp versus the world. That's what we're going to call this. I like it. No database, as we mentioned earlier, and what Fabio said, which is all the things in one file. But I specifically said things just to be vague. Can somebody be more specific on that? What are the things on the server side that are all in one file right now? Yeah, all the things in one file, which includes routes, like all of the different app.get, app.posts, any other functions that we have, as well as our database functions, or database, not even functions, but objects. All of that seems to be in one file. So that probably is not how you build a scalable, maintainable code base where there's hundreds of routes and many different types of entities like URLs and users. There's not just 2. There's like 50 of them, right? Or more. And so you don't want them all in one file. Why do you not want them on one file? It'll still work, but it will not be very maintainable, right? It'll just be chaos in terms of trying to manage it. As far as JavaScript cares, everything could be on a single line for all it cares. Right? Like literally one file, one line, good. For us, maintainability-wise, we need to organize things a little bit better. What else? What else in TinyApp do you feel could be is missing from what you would need in order to deploy it? Security? Can you elaborate? So security, passwords are all stored on the server. What's your name again? Anne? Anne is saying passwords are all stored on the server. Where else are they going to be stored? Elsewhere, like where? Different servers or something like that? So yes, but it's not uncommon for the passwords to be stored in some kind of database. Right now it's stored literally in the process that it's running, so it can be erased very quickly. That's one problem, as we mentioned. But the other problem is, like, you probably don't want your passwords there. Did you notice, did you guys, some of you started using cookie, what is it called, that library? Cookie, not cookie parser, the other one, session cookie or cookie session. I always get confused on the name. It encrypts your cookies, right? For those of you who have gotten to that point. But you have to give it a string of something. You have to give it like a key, right? Where are you putting that key or that string? In the file. So it's not just passwords. It's also secret keys. In our case, it's only for that one library, but there's many others that an app would need. Those secret keys shouldn't be in the source code. Why? Why shouldn't they be in the source code? Right now, they're just hard-coded, right, in our JavaScript file. Well, who uses the source code? Who has access to the source code? Devs. You know, in a company like GitHub or Facebook or whatever, there's thousands of them, hundreds or thousands. Should they all have access to the production database and all the production APIs and keys, such that they could look at any user's information? That's a privacy issue, right? So the security and kind of privacy issue where you don't necessarily you want them to be able to run stuff locally and have their development copy of a database that they can play with and they can build on, which mimics production, what's kind of being used in the cloud. But you don't actually want to give them access to all that data. Startups tend to be okay with it. They're kind of smaller companies, small data sets. They want that agility. You know, giving them that access gets them more control and more ability to do more faster. But it doesn't. Large enterprise, even mid-sized companies, tend to have then proper processes where they need to separate that stuff out. And these keys need to be separated out, right? But also, it's not just the devs. The source code could potentially leak, right? Or you have ex-developers that still have that on their laptop because they cloned that repo. Maybe they worked for you 2 years ago, and that laptop gets stolen, right? Like, those keys are now out in the wild. So it's not just even the devs that you have, even if you trust those. What you don't trust is what other hands it could get into. So just because startups give devs access to the server, the production server, sometimes doesn't mean that they actually put the keys in the source code, right? Those are two separate things. Victoria, thank you for that gesture. The web address. Yes, Terrence. Can somebody elaborate on what you think Terrence means on web address? Yeah, the URL and the port, is that what you were going to say? Yeah, it's not running on localhost 8080, is it, or something like that? Whatever we decide, 3000 is common, 4000, I just pick random numbers for mine that are just in the thousands. It's not going to run on localhost 8080, right? So some thought needs to go into, well, what's the address going to be? And the other thing is, more importantly, it's not going to be HTTP ideally. It's going to be fully HTTPS if it's going to be modern, right? We talked about security yesterday. You had a lecture with Johnny about some of that stuff. I think that was yesterday, right? How was that, by the way? Was that his first lecture with you guys? Yeah. He's an alumni, as you mentioned, right? Pretty cool, right? So yeah, you want security. Most apps these days, they're not doing HTTP, so HTTPS, right? These are just some of the things. But what are the things that we are doing well in TinyApp that you would want to ship with, you wouldn't want to change necessarily? Maybe there's going to be a smaller list here, but there should be some things. Like actually having user authentication logic is so common, and I would say maybe the code isn't the most ideal in terms of how we're doing it, but the workflow, the idea of these login and sign up forms, they're pretty common. And so specifically user auth, I'll put as a major bullet, but then there should be sub bullets. What do we have under user auth that we're using, aside from what I just said, that is pretty real world? What are some of the things we're doing? Fabio, you're awesome. Password hashing, absolutely. That is something unfortunately not all companies do, and when their databases do get hacked, literally passwords leak, right? Clear text passwords are much easier to hack because you don't have to do anything. You just literally type it in somewhere. So password hashing is very real world. We use bcrypt for this, but there's other algorithms and libraries that could be used. Bcrypt is also very real world. It's not just some toy one. It is used, probably it's the main one that's used. So we're actually learning that, which is pretty cool. What else? Even just under user auth, what else are we? What other things are we doing that's pretty real world? I'm going to give you a hint, but that's not the answer. Something to do with the cookies that we're setting. Yes, we're encrypting cookies. We didn't have to do this. We started off not doing it, right, in the assignment? And then we're like, oh, that's not so secure. And so we encrypt them now using that library that the name I can never remember because it's so confusing. Right, we're using cookie session or session cookie or whatever. It's a very confusing name and misleading because it leads students to think, or new learners to think, that session cookies are always encrypted. Because it's by default, it encrypts the cookies. So please do not think that session cookies are encrypted. If you're confused about that, write it down as a thing to bring up with mentors afterwards. I'm not going to talk about it too much in this lecture, right? If you're not even sure what session cookies are, write that down as a thing to learn about or talk to a mentor about. Yeah, so those two things we're doing quite well. Those are commonly used libraries. Anything else? What else is there that we're doing? It doesn't have to be under user auth. What else are we doing that is real world? Sorry? Unique user IDs. Yeah, I mean, you kind of need that, though. It's hard to not have that. Error handling. I'd say we do this mediocre in TinyApp. We don't have the best user experience. I would say the UX is actually on this side. The user experience is subpar intentionally because we don't want to, obviously as we get further and further into the program, we're going to improve on those things, but we don't want it to get in the way of the core learning. Right? We don't want you to develop bad habits in user experience, so we have to nip that in the bud. But at the same time, too much of that means then it becomes a user experience module, not a web development kind of stack module, right? So I would say the user experience is subpar, but we are doing some error handling, 404 pages and things of that nature, right? Where does testing fall in? Nobody mentioned testing. Remember that in our new program, this 12-week version, unlike our previous one, we start with automated testing essentially in week 1. You write your assertion library, and you start using that. And then by the end of that weekend, you're doing Mocha and Chai. Where's that here? Right? So would that be in this list here? This one's a big one. Right? Startups sometimes will not do automated testing, and then they'll regret it later. I've been there. So it's not that every company that you'll join after bootcamp will do this, but they ought to be doing it to some extent. And it's not a binary do or not. It's how much are you doing of it, right? And then the fact that our actual stack that we're using, Express, Node, right, NPM, these are actually used quite a bit in production. These are not, Express is not a learning tool. It's real world. It's lightweight, but it's real world. Pretty cool, right? Any questions or things that I've forgotten or missed here? Got my thing. No. Okay. We're going to be going deeper into some of these things that we want to maybe doing better, right? I'm not going to talk about database today. That's a little bit, that requires more than a half or full lecture. So that one's going to be a bit tough, but it'll come very soon. But we are going to talk about all the things in one file. We are going to talk a little bit about user experience. And the other thing is, yeah, those are the main ones we're going to talk about. Automated testing. You'll do a little bit actually as part of TinyApp. A little bit. So there's that. But before we do, let's talk a little bit about HTTP. So the most important things about HTTP, I know this has been covered before, but it's really, really important. I would say that like how HTTP works is request response. It's very transactional, right? So what makes a request? What are the components, the major components of a request? URL, Fabio says. URL, okay. What else? There's one more major thing. The verb, yes. The verb, and you called it the method. Remember your name again? Jake. Jake said method, which is synonymous with verb in the world of HTTP. So the examples of that are that we've used, get and post, right? As it turns out, a lot of modern web applications, not all of them, tend to actually go beyond just get and post. So that's something we're going to talk about as well. And I'll write down here, not just get and post, but also other HTTP methods, verbs. We'll talk about that a little bit today as well. Those two things make up a request. And we know this because in Express, when we say we want to handle a route or a request, we create a route, and that route has those two things, app.get, that's your verb, and then the path, right? And what makes a response? Data, so that's like, let's call that the content, right? Status code, right? That's a number. Whoops. Tells the browser or the client of any kind really what the server is trying to convey in the content. At least the intent of the content, if you will, right? Anything else? There's many other things. Yep. Yep. We'll just put other headers / metadata, right? This is where things like cookies come into play. You know, caching and expiration of the page. What kind of format is the data? That's another one. Format is pretty important. Is it HTML that's coming back? Is it a CSV file? Is it XML? Is it JSON? Right? What's coming back? What kind of format? How should the browser interpret it? It's pretty important. But definitely these two very key, right? Now, I wanted to also review a little bit because I find that, you know, when I'm looking at where people are usually in this week, is that they're still a little bit confused about that whole kind of workflow of like, I want to create an entity, let's call it URLs, in this app. What does the actual flow look like from a HTTP perspective based on what we're building? Because it's so easy to get caught up in the, I'm building this, then I'm doing this, then I'm doing this. It's like, wait, what's the flow again? Like what? There's a lot of stuff happening. So would it be useful to do a little bit of that kind of flow of like what happens, even as a bulleted list here. Everything from like making that initial request to get the form, to submit a URL to TinyApp, all the way to it being created and what that looks like. Can we do that for like 5 minutes or so? Yeah. So what does that look like? What's the first thing that happens? Yeah, user navigates to some URL, right? By clicking a link or by directly going to that URL. So let's call that slash. Instead of talking about URLs, let's talk about a different entity. So let's do articles. Just keep it simple. Yeah? So they navigate to articles. But it's they want to see the form where the articles is. Do you think it'll be at slash articles? It could be. It could be like there's a list of articles and then there's a form right on that page. Or the form could just be on a separate page. If it's on a separate page, it might be on a URL something like this. Articles new, to create a new article. Okay? What happens at that point? I'm just going to kick things off so we get an idea of what this is going to look like. The browser makes a GET request to that URL. What happens after that? Like, let's go as step by step as we can. Server, yep, so Express gets the request and needs to decide which to invoke. Not yet. The page isn't rendered yet. We're not there yet. We're still like we're now in the Express code. This is not our code. What does Express have to do? Which route? Yeah. And how do we define the route? What actually defines how we handle a route? Let's call that a route handler. How do we define a route handler? Post, no? I think you're onto something though. It could be a post, it could be app.post or app.get, right? But it would look something like this, wouldn't it? App.get. And what's this part here? This is our handler, right? Let's not forget what we're writing here. What did I just write? It's a function. It's a callback function, isn't it? We covered callback functions as early as the prep course, but really in depth in week 1. Again, when you're sometimes doing this stuff, it's easy to forget what you're doing. You're still working in JavaScript. This is a callback function. So if I have a whole bunch of app.gets, what I've done behind the scenes is in Express, I've registered these callback functions in some kind of a lookup table. Is this useful? Am I going? I know it's maybe a little bit of a basic review for some of you, but we're going to go, like, I bet you didn't think about that part, right? That it's not just our code. There's Express that we're leveraging. There's a reason we're leveraging that, right? This is just marked down for like code snippet, so please ignore that part, just looking at these 3 lines. Okay, so it gets the request and needs to decide which route to invoke. Then it obviously figures that out. So, and it uses the 2 most important parts, the URL or path and the verb or method, as we call it, to figure out in this lookup table which callback function to call. And then it calls that callback function. Because we're not calling those callback functions. Express is, right? Agreed? And we know that it passes in two things: request object and response object. Request is for us to read. Response is for us to write to, or usually write to, right? To decide how to actually express how to behave. What happens after that? Now it's our code. We're in our function, right? And we start having logic. Now this is specifically about articles new. What do you think would be happening there? Would we be creating an article at that point? No, it's a GET request to fetch the form to fill out articles. Yep. Did you want to take a stab at it? What was your name again? No, you raised your hand, didn't you? No, you didn't. Okay. Did you want to go for it? You mentioned the word redirect. At this point, I'm fetching a form. I don't need to be redirected to the form. I need to see the form. It will render our code. Well, let's call that the handler code. Will render the form. In our case, let's assume we're using EJS, right? So in this case, express/EJS will read the .EJS file from disk, right? Run through the EJS template with any dynamic data. What's the result? Result is a string of HTML from the EJS file, right? Something like that, right? Sometimes you can pass in data here, right? By the way, notice I didn't use the word template vars. That's just a variable name that we're using. I find that students sometimes are confused about that. They think it's something special or magical to express. Remember, you're writing JavaScript code. When I say let something equal something, I've decided to create a local variable. I could have not created a variable and just used the right side of that directly, right? That's what I'm doing here, just using that object directly. So far, so good. I'm going to pause here. Hopefully, you guys will think about what the next thing could be, potentially. So we've just called res.render. We've written down the sub-bullets of like EJS being involved in getting that HTML ready for us. Is it Jake? Yeah. Express, yeah, you're onto something. So Express will use, which library do you think it uses behind the scenes to communicate over HTTP? Yeah, you've used it already. HTTP. Remember require HTTP from week 2? Yeah, it actually uses HTTP behind the scenes to send the response data, headers, etc. that you set, right? Now, while this is happening, there is a TCP connection open between the browser and the server. It's waiting for a response, right? So HTTP library behind the scenes uses the TCP library that we also played with, right? So if I wanted to go a little bit deeper, I'll just do it for purposes here. So as a sub-bullet, more of a module, I guess, to accomplish. And then after that, the browser, of course, receives that response, right? Let's assume it was a 200 with the form data, and essentially renders that HTML Now, there's a bunch of stuff that ends up happening here. I'll put this as sub-bullets. Does anybody know what happens once it encounters our tiny app HTML, for example? Does it have to do anything else aside from just render the page? Or while rendering the page, what else does it have to do, I should ask? The browser doesn't understand the idea of logged in. I understand it's cookies, but I was kind of putting that aside for a bit. In terms of the actual, like, I need to display this page. What does it need to do? Assuming, again, just visualize your tiny app code in terms of whatever's in that EJS file. Yeah. So this is a common misconception. The if conditions that you have in your EJS file, which is written in JavaScript, are actually taking place before the browser gets it, because the browser doesn't actually know how to read EJS. I think that's you were talking about that if statement in the EJS file, right? So that stuff actually I should have mentioned here. Any JavaScript tags or any EJS tags, so it's these tags here, are interpreted at this point by EJS and removed because browsers don't understand them. So they're essentially server-side logic to decide how to render the HTML and what to render when. What I mean by that is when we view source on the returning HTML, there is no if, else, or anything like that at the browser level. Now, there may be client-side JavaScript, but that's another thing that we haven't done much of or any of. So I forgot to write that down as a thing. There's no client-side JS files here. Well, we're working at that next week. Yep. So the question is, how does it know to continue to loop through the page so it knows to continue to display? Can you elaborate a little bit? I don't know how it like. Why is the page still on the screen for longer than a split second? You're trying to reconcile it with like essentially like a game loop or something like that. The browser doesn't. It has a loop as well because it's running JavaScript. This is getting a little bit off topic, but it's essentially decided to paint something on the screen and leave it in that state unless there's some other code that's going to change that state. There is a loop. Let's go with there is a loop and there is a paint loop that happens. It's not necessarily exactly a loop, but there is like a constant kind of thing that's running to redraw the page as it changes. Yeah. But there's something that I'm looking for here that nobody said yet in terms of what it needs to do, even for our tiny app page. Fabio? Render it? But yes, but in order to render it, what are some things that it has to think about? What's in the HTML that comes back? Let's bring something up. It rendered this whole page. So a lot of stuff happening here. Right? Of course, there's some Trump news on there. Shouldn't even bother with news, right? All right, let's not, maybe this wasn't the best. Okay, I'm gonna go to another site. Here. No, there's too much news on here. What's, like, if I view the source here, I'm not gonna find any EJS tags or anything, even if they're using something like EJS. Sorry, did you want to say something? No. So the question is the relationship between EJS and HTML and kind of how that works with the browser. EJS would return something like this. This is the source. The entire page comes back, right? And it is a string because HTTP is all about sending text and strings, right? And so it starts with the HTML tag usually, because that's what we've put in our EJS files, and it ends with the HTML tag. And within that, there's going to be body, head, and things like that. But in our EJS code, we have these if statements. We have for loops. You know, we say something like loop through all the URLs and render a table record, a TR. What happens is when EJS is running, it turns that loop and it creates multiple table rows. But the browser can't do that. I mean, not in that way. And so when the browser gets that HTML, it just looks like a whole bunch of TRs or table rows inside a table. It has no idea that EJS was used or some alternative to EJS was used to dynamically loop through an object to create 10 rows. It doesn't care. It just wants, what are the rows, right? And so, does that answer your question in terms of the responsibility there? What happens is let me actually illustrate it a little bit more visually here. Separately, not as part of these steps. So it goes like this: browser to express, right? And express, in our case, we're using EJS. So once it goes to our callback function, let's say our callback function decides to do a render using EJS. At that point, the EJS library is used with whatever file we've decided, right? And in there, the output of that is HTML string, right? Which starts with HTML, usually, and ends with HTML. And it does not have any more EJS code in it. But it has done the loops, it has done the if statements at that point. It has put in whatever data we passed in through those template vars, right? And so this is what the browser knows how to interpret and construct into a web page. It could have been that we didn't use EJS and we just literally had the string in memory or the string in a HTML file that didn't have any loops or anything like that. But we needed a little bit of dynamicism to be able to loop through our URLs and render a table. So we needed to use something like EJS, or wanted to make that convenient for us. But ultimately, the browser just gets that entire HTML string. And then my question is, what happens after that? That's where we're at right now. Does that help clear that up a little bit? Maybe. If not, we can talk about it more after. So the browser has to render or paint this page. But how? Yeah. There's definitely like goes through the HTML and figures out the structure, right? So it parses the HTML. And what is it going to find? The reason I brought this up is, look at this stuff here. It's not just content. It's links to other things. Exactly, that's what I was looking for. So, parses the HTML and starts to come across links. right? If we were to look in the network tab, and this one's not a heavy site, but we'll still see in the network tab when I refresh, there's a whole bunch of different requests. This one's a very simple page, but a New York Times, let's just take a look here. Will it ever stop? I'll say you can look that up. I use Command Option I, but definitely when you come across questions like that, you can ask, but sometimes you can just, I need to figure out how to do this and do that. Not to, yeah. This took a long time to load, not the most responsive page, but a lot of like requests were made after it got the HTML back. Once it got the HTML back, it's like, oh, I need to like run this thing. I need to run this JavaScript. I need to, download this icon, and so on and so forth. So a lot of stuff had to get downloaded as well. And in our case, we're using Bootstrap off some external CDN or something. And so it needs to go download that stuff as well. What happens next? This is at the point the page is rendered. Now the user is going to fill out the page and hit submit, right? Is this still useful still, or should I speed it up? Useful? Seeing most heads nods. I want to go into detail here. The user just hit submit. Tell me what the browser does. Yes, but I want to go more detailed. Ultimately, you're right. Like browser will send, and I'll even ask you more details about that. But there's some steps before that. Try to be just whatever your knowledge is, however deep your knowledge is, try to go there. Yeah. Yes. Browser looks at the form details, specifically which things? The method and action attributes. Because remember, it needs to make a request. It needs to know those two things. They're called something slightly different than verb and path, unfortunately. The naming's a bit conflated, but those are those two things, the path and the verb. Right? And now it's able to uses that info. For example, in this case, it would be a post to /articles, maybe, to create a new article. Yeah? So now a post request has been sent up. Oh, and we should also mention that all the form fields are sent up as an encoded string. It's called form URL encoding, essentially. So it's like something like this. Title equals Trump something or the other, right? And maybe there's a author, right, for that article that was part of the form fields. So it'd be like and author equals whatever, and category equals, U.S. politics. And notice I put a plus there because it encodes things so that it doesn't have to deal with spaces and special characters. Like an equal sign is going to throw it off, so it encodes an equal sign. An ampersand is going to throw it off because it's part of the syntax here, so it encodes those things, right? Right, there could be more stuff there. What happens next? Just like before, Express will receive the response, right? Or request. Express receives the post request with the form body or data, the form data. Yes? At that point, we could jump to like we need to handle that request or our callback is called, but I'll go a little bit deeper into Express again. And the request object has this string that I've just constructed here, right? This example string. But Express, that's not a very easy string to work with. We're going to have to like call split on it at ampersand and then split again on equals to separate each of those key values into essentially an object, since key values are best represented as objects in JavaScript. So instead of us having to do that, we don't do it, do we? We don't call split on this string here. How do we get this turned into an object? Because ultimately, our code is able to access the form data using request dot. Do you remember? Request dot. Nope. Body. Params is for the URL stuff. Body for the form body or data. Somebody already answered in Victoria. Body parser, nailed it. Not Express, but specifically body parser. That's why it's called body parser, because it parses the form body. Takes that string above and turns it into a nice object for us to easily access that data. So it'd be something like title Trump something, author, KV, and so on. Does that make sense? That makes our life easier. So we're using this other middleware called body parser to actually do that for us. Yep. Why doesn't Express do that is a question. Many other frameworks that have different opinions do it. Said do. Right? They end up deciding that that's so fundamental that you're going to do it almost every time, so we're going to support it. Yeah, so the question is valid, which is, well, then Express must be thinking about situations where you don't need body parser, and indeed there are. Let's say you're building an API where it's JSON-based, and even then you can decide to do this or not, but let's say there's post requests coming in, but you want the post to be formatted as JSON. In that case, you're not getting it encoded like line 74 there. You're getting it encoded like JSON. And so you would not use body parser. You would use JSON.parse, I think it is, right? JSON.parse. So Express is often used to build APIs. I believe LinkedIn's API is built with Express, I believe, last I checked. So, and if you're a developer working with their API, maybe it handles post requests with JSON only. It doesn't want this form encoding. Then they wouldn't use body parser on their side. Good question, though. Does that make sense so far? Right. And then Express executes our callback function or handler for the post request. Right. We're not done yet. It's taking a bit longer than I expected, but I think it's useful. What's next? Express calls our function, so now we're in our function. What does our function usually do with the post request? It needs to like change the database, right? It needs to add that article. So we're going to do things like our code will validate the data. And assuming it's good quality data, like it's not empty title or something like that, it will insert the data into a database or object, in our case. And it will respond with something. How do we traditionally do the response with a successful post request currently in TinyApp? You're right, but the word render is incorrect there because we don't use render. we use the function redirect on request. The request object has a function render, but it also has a function called redirect that we use. And what do you think would be a valid redirect? Perhaps going back to the articles page or something like that, right? What does this do? What is the redirect function behind the scenes? What is it doing? The render function, we know, uses EJS, finds the file on disk, and runs through that EJS library to get that stuff done. What does the redirect function do? Does it use EJS? Is this an EJS file? Exactly, which sends back a redirect response. What does that mean? So a redirect response is what? It's a 300 series response, usually a 302 or something of that nature. So HTTP 302 with a header that says location articles. This is an HTTP header because we said responses have headers. This one is critical. When a browser sees 302 or any of those 300 series, it looks for a location header to know what to do next because it needs to make another request to that location. So at this point, and instead of rendering a page at this point, like we talked about before, it looks for location header in the response and performs a GET request to that location. So in this case, it's /articles, right? And at that point, we're back to like handling a GET request. We've already done that once before, so I'll speed that up a little bit, right? Which is basically, again, express, then R code, then probably EJS to HTML as a response to the browser. So I wanted to review this a little bit because a lot happens when you click that submit button on that form that you wrote, but partially express is involved, and there's some middleware involved that's parsing body, all of this stuff. It's easy to lose track of like the big picture of what's actually happened from a lifecycle perspective, like the whole GET request, then the post, and then this final GET here. Right. Any questions or additions that you think I should do here or anything like that, or concerns? Okay, so we're going to take a break here. And then after the break, I'm going to talk about REST, which is something we didn't put in our list because we don't know about it quite yet, and some of the other things that we listed that could be done better. Okay, cool. We'll re-adjourn in 10 minutes. Hey, what's up? Yeah, so we'll do that next week actually with the Twitter clone that we'll build. You, there's none of it, right? But that is a common pattern. It's not undone. Yeah, there are definitely better ways to do it, but you don't replace the server-side checks because, yeah, you might want to do some client-side checks like, you know, it's required, it needs to look like an email. Now, HTML even does that for us, right? Like required input type equals email. Now, you don't even have to do email checks, right? So it's nice that modern browsers can do that for us. But let's say you wanted to make sure the email was of certain domains, like only Google and Hotmail, right? Well, you're going to want to go in and do some checks on the client side maybe before you let them submit. But in case those checks are disabled, like they just disabled JavaScript, or they just went into Inspector and like turned off that JavaScript, specifically those files, you're still going to need server-side checks. So it's not that you don't ever evade that. So it's kind of fundamental, and then you can add better user experience. Because remember I said terrible user experience? That's part of it, right? Like we could do better things with client-side JavaScript. We're not doing them right now, but we will next week. Totally still something, well, not re-rendering, but server-side validation and then rendering the validation errors is definitely something you do regardless. Yeah. Now, if it's an API, you're not rendering HTML, but you're going to come back with an object that says like errors and then an array of all the errors, right? Same idea. Yeah, no problem. Hey. Oh no, I'll be including them in the notes. Yeah, I forgot to mention, but this is gonna get compiled into notes that I'll send. I have a meeting right after lecture, so they probably won't get sent out right away, but they'll be in there. Do you need them right away after lecture, or are you okay with like an hour delay or something? Yeah. Yeah, I'll clean them up a little bit. You know, it might be like a couple hours after lecture, but I will send them out. It was good feedback because it's my first time doing it. In terms of like in the new 12-week format, you know, we have this extra, more detailed kind of lecture. So yeah, I wish I could visualize it more on the whiteboard, but then it becomes challenging with satellites. So that's why I did it more in the text file. Yeah, yeah, yeah. Most websites, unless almost all, even sites, like forget applications that are very complex, like GitHub or Facebook, or somewhat complex like Tiny App that are dynamic. Imagine like just a dentist office. Like here's our map, here's like our contact in details. It's just informational. Even something like that, like a static site, is nowadays in the modern world. Like if you were to build one today, you would probably use like modern tools that you're going to learn in this program that are going to generate the HTML, but not write the HTML from scratch, because there's just so much repetition in HTML, like the whole layout, partials that are repeated, that you're going to want to dynamically create the HTML. Exactly. And you've already included partials and stuff in EJS, right? So you kind of want that stuff so you're not repeating yourself everywhere. So you're almost never writing static HTML files. The only time I can think about it is like if you are creating a mockup. But even then, people tend to use tools that generate HTML, and then again, it makes that code more maintainable. Yeah. No, so you're still linking JavaScript and CSS files, but you're just the HTML part itself is usually like a rendering like a rendering library like EJS or React, which we'll learn later on, which is more powerful. And React is actually used for static sites too nowadays. If you look up Gatsby, or maybe you've already heard of it, it uses React quite heavily to do static sites. So some of our students who end up doing some consulting to build like site projects or whatever, or just their own personal sites, they'll use Gatsby with React because they want to brush up on their React or want to use modern tools. So it's picking up a lot of popularity. I think they just raised like 15 million or something ridiculous. But check out Gatsby; it's pretty cool for static sites. Yeah, you might want to, if you're into like front end dev and building sites using some of these tools, then Gatsby is one of the ones to look at. Yeah, no problem. And then look at Jekyll as well. That's more of a traditional, but it's again, you're not writing HTML, you're writing like ERB or something like that. So Jekyll and Gatsby. Okay, we should be resuming right now. It's 18 after. We took a break at 7 after. So let's get everything sorted. Um, okay, so we talked about a bunch of stuff in terms of review of the entire thing, and I'll send this out when I clean it up a little bit after lecture. I have a meeting right after lecture that I'm going to jump into, so it won't be like immediately after, probably a few hours after if that's okay, right? But it'll be included in my lecture notes. Um, we did a little bit of Express review already because we incorporated Express quite a bit into our workflow of what we wrote down. So I'm not going to do as heavy of an Express review. We talked about template vars and stuff like that, so I'm not going to go into that too much. You may still not fully understand template vars. You may not fully understand EJS. Just remember, you're still just starting your learning journey with this stuff. You're not expected by the end of this week to be like fully be able to build Tiny App from scratch without any help. It will still take some mentorship and or tutorials to be able to do that again, and that's okay, right? I want to talk about REST. So we've kind of avoided REST intentionally up until now. But today you'll read a little bit about it. But we don't really implement it much in TinyApp. So this is not so much about setting you up for TinyApp. It's more about just, again, the real world of what web apps do often. And REST is one of the things that most modern web applications use. Not all of them, because there's other alternatives. But it is a pattern that's applied to how the routes and how the kind of the API of the web server is created. So what is REST? Anybody want to take a stab at this? What is REST? Yeah, you might have heard the term REST API. Yep, representational state transfer. I hate this because it tells me nothing, right? At least with HTTP, you get an idea, right? It's a protocol. You get the idea that it's like hypertext. Okay, I could look more into that. And then it's text-based. That tells me something. What the hell is this? So the meaning itself is fairly, the words themselves are fairly useless. Anybody want to take a different stab or go further into explaining this in English? I see one hand up, but before I go there. Just one hand? Okay. Go for it, Fabio. Of thinking about the communication of data, right? And you call them objects as an example. Yeah. Okay, this is getting a little bit more specific, but still quite vague, right? So now it's giving us kind of a standardized way. We could choose to leave it, use part of it, or use all of it, or even kind of tailor it to our needs. Of thinking about this, we know we're going to use HTTP, we know we're going to use GET and POST and things like that because we're using HTTP. But can we come up with like a standardized way to like think about this stuff? Now here's the problem with REST I'm going to lay out right away. There's the white paper of REST that came out years ago. And there's REST today, which is actually not the same as the white paper. So when a lot of developers, web developers, talk about building RESTful APIs, there's some semblance to this original white paper that was published around what REST ought to be. And today's REST that they actually implement is like taking that further and changing it a bit. So it's a conflated term. I'm going to say that out there. So when we say REST, we're going to talk about, some people call it, I hate it, but they call it Rails REST because Rails actually was one of the frameworks that like mutated REST to be what REST is today. It's not anything specific to Rails. It's just that they kind of added more things to REST that now become kind of that REST standard, even though that's not what it originally was. Okay? So another thing to throw confusion into it. So we're going to be talking a little bit more of stuff that includes this as well. Okay? So what is it then? Anybody want to go a little bit deeper into what that actually means in terms of standardized way of thinking about the communication of data between server and client? No? Okay, I'll take a stab at it. So far what we do is we have these routes, and we say we are going to use GET and POST for them. Right? The RESTful way of thinking about REST basically makes you think about your routes more deliberately, not just some kind of random organization of them. Okay? So the idea is, well, let's use GET and POST and even some of the other HTTP verbs to map with what we're doing with data. Because what are we doing with data? Often we're doing create, read, update, delete. Right? We're usually doing CRUD. Right? And we know for read, we have different types of pages. So we have like reading a collection. So that's like give me that list of articles. When I go to Hacker News, I get a list of all the articles, right? And then we also have read a specific detail of a specific article, like I want to actually view the whole article when I click on it, right? And then we'll talk about update, delete, and create a little bit as well. Now, what do we use for create? We use post with HTTP, right? And so REST says, yeah, you should use post for create. And if you're dealing with the resource, and the word resource comes up a lot in REST, because you think about each of these entities as resources. An article is a resource. A URL, in the case of tinyURL, is a resource. A user is a resource. Okay? So the word resource comes up a lot. And you think about your paths as they map to these resources. So in this case, if we're dealing with articles, it would be, the RESTful way would be to say it should be /articles. Now this is more of the modern REST way. This is not what the original white paper said. This is what REST means today, okay? /articles. With read, we know we use gets. So it's always going to be get for read. We're not changing any state on the server. And in the case of a collection, the modern RESTful way is just to use the same path, because you're reading a list of articles. Now, you might still add additional parameters, like page equals 1, or sort order equals whatever, right? But ultimately, that's additional optional information on the path. The path is still, the majority of the path is still this /articles, right? And then for the case of a given article, now you're wanting to access a given resource, it's going to be either article or articles. It depends on, again, this is a little bit more nuanced, so you can decide which convention you want to go with, / the ID of the article. So I'm just going to use that express convention that we use, : to indicate that. But that's not what it looks like in the browser, right? It'll actually be a number or a string or something like that. What about update and delete? Well, if you're only going to stick with get and post like we are with TinyApp, then you can use post, because that's changing state on the server. You're posting new information, although you're updating, so it's still new information. It's just new information about the same thing. But in that case, you cannot do, I mean, I guess you could do something like that. You could do post articles ID. But REST says, instead of using, again, modern REST says, instead of using post, you can use put or patch. There's two different verbs that exist in HTTP that you can use to update content or replace it. So patch, as it sounds, it's like giving deltas, like, oh, the title's the same, so here's the description that's changed, and the author has changed. So I'm only going to give you the author and the description. Everything else, don't touch, please. Keep it the same. That's what patch is meant to be for, to just update parts of the thing, of the resource. And then put is meant to kind of replace the whole resource. In practice, they are misused all the time. Even in Rails. When Rails first started doing REST, it used put for everything, even though it should have been using patch. And so later on, they implemented patch, and now they support both. It's kind of confusing. Okay, so don't get too caught up in the, it has to be this. Remember, we can just use post if we want. Okay? And then for delete, as it turns out, there's another HTTP verb that exists already called delete. And so we can use delete /articles /ID. Otherwise, if we were just using post, we would have to say something like /delete, right? Because the path would conflict with the verb. Like there'd be the same route again. And because we're using a different verb, we can use the same path. And it's not the same route, right? We now have a unique pair of verb and path, which means a unique route. Right? What if, let's take these things further a little bit. What if it's similar to what we're building, what we saw here, Hacker News? What if it's something like this that we're building? And we want to be able to support this like functionality. Right? Where you can like something. Or we want to support comments. For a given article, when I go into the detail for that they call it item. Let's assume it's called article with this given ID. They give me comments, right? What if I wanted to support that? What would the routes look like for this? And I think this is an important exercise because very soon you're going to hit your midterm projects, right? It's in a few weeks, comes very fast. And you're going to need to go through this exercise of defining these routes for whatever app you decide to build. So we're doing it a bit early, but I think it's good, right? And then when you come back to the midterms, you'll again go through a little bit of that exercise again before you start coding it. So yeah, what should the routes be for not just one resource, but let's say comments. Let's start with comments. How would I support comments in terms of my, how would this look? I need to be able to CRUD comments. What would the routes look like? I'm leaving that blank so that we can fill it in. Yep, Jake? You're right. So maybe the Hacker News thing is a little bit confusing. But let's say you wanted to be able to get to, maybe there was the news article itself, and then there was a separate request to get the comments, right? Or when I'm submitting the comments, I'm submitting to a different URL, right? I'm not submitting an article, I'm submitting a comment. So that still holds true. Yeah, I mean, we could allow create to just be comments, /comments, where you have to specify the article, let's call it article ID or something like that, equal to some number so that we know which article you're commenting on. Comments must belong to an article in this example, right? You could do this. But usually, and this is not always done, as we can see with Hacker News even, this is a required thing. Like in order to view an item, I need to know the ID. Usually the convention is to put that as part of the path, not after the path, not after the question mark, because that's usually optional information. Not always, as we can see. So let's take that better approach than what Hacker News has done. And instead of doing a required thing in order to submit a comment, we're going to put it into the URL. That's, again, something that modern REST talks about. So here, similar to what Jake was saying, you'd actually say articles, or article, whichever one you decide, /5, which looks a lot like, or sorry, /ID, which looks a lot like this, but then we add /comments to it. And because that ID is required, now it's part of the path. You cannot get to comments without that ID. And the same would be true. So this would be a post. The same would be true for reading, right? If you just want to get the comments and not the article details for a given article, you'd say, for article 5, I'd like that comment, right? Here, though, I need a comment ID to be able to just click into a comment and see the details of that comment. Maybe it's like read more or something like that, right? So here, if I say ID, it's kind of confusing. So convention, when you're building an app using Express or something like this, you can't just use ID twice here. So you'll say something like article ID, actually. So it's very obvious which thing you're actually talking about, right? But ultimately, it'll be a number or a string or something like that when we see it in the browser. And when we're updating a comment, we need the comment ID, right? And when we're deleting a comment, same thing. We need the ID of the comment. Agreed? And the same would be true with likes. You would maybe, instead of the word comments, you'd use the word likes. So this is getting into the idea of a nested resource. Comments always have a parent. They always have article as their parent. The article ID is required. Therefore, they are nested within the sort of parent resource of article. Right? Now, as you can imagine, this could be endless, right? Comments could have likes, or comments could have comments. And so you could easily, this URL could become quite nested, quite deep, right? Yeah, exactly. An example would be YouTube comments, but even Hacker News we see that, or Reddit is a great example, right? So you can decide how much you want to nest here. And generally, this is more convention again. Modern REST says don't go more than this. Don't try to go 3 or more. So what that would mean is that if I want to be able to like a comment, let's say comments have likes, and you just want to be able to maybe create them and that's it. You don't want to have a list of likes or anything like that. The URL for that, to be able to actually click that button to like a comment, as I can do here, right, to upvote it. We'll just stick with likes. Would be not something like this, where you are submitting a new like to the collection of likes that belong to a comment that belongs to an article. Because the comment ideally has a unique ID, as we see here. And so we decide just to avoid kind of too much nesting. It's not necessary that we need the article ID anymore. So we can just say comments ID likes. So we essentially start from, like, just look at the immediate parent if we really need to. Right, so we're only going one level in. This is, of course, assuming that comments have a unique ID. Not like comment 1 is repeated for every article, because if you had comment 1 for every article, then you're upvoting all comment 1s for every article. It needs to be a unique, globally unique ID like you're doing with user IDs in TinyApp. Right? So we've applied REST to our kind of example of Hacker News or some kind of site like that. I wanted to talk a little bit next about code separation. You've already created some helper functions in your TinyApp, or if you haven't, you will soon, right? To be able to generate the random string, for example, for a unique ID for a user. Well, we want to be able to separate our code out into modules, right? We said we don't want everything in one giant file. How would we go about doing that? If I was to look at this example app that I have here that has a server.js, right? Whoops. Looks like something like this, just boilerplate Express. There's no routes or anything like this. We're using EJS. We're using body parser, and that's about it. There's no routes yet. In order to actually add functions that we're going to use to either look up users or things like that, we could use additional modules. We know how to use modules. That's just JavaScript. There's nothing special in Express with regards to modules, right? So I could create a folder called helpers or libraries or something like that to create additional modules that I can create in that folder, right? And is there an example, right? So in here, I can start creating functions. Just faking it out for now, right? And then I can, instead of putting this code in my server.js, where it's going to start getting messy and too much, I can simply just require that file. I can decide, okay, you know what? I want to extract this. You've done this before in week 2, right? You've used existing modules. You've built your own with Lowtide. So this is probably familiar territory for you. And in that case, in order for this to actually work, I need to export an object from here that contains this as a key, right? So I can say module.exports equals and specify that like this. which is kind of verbose, and in ES6 we can just do that. Right? So that's kind of one thing that we can start doing, is to start separating out all our helper functions that we need in order to run our routes. And then what's nice is, another nice thing you get by separating out into modules is testability. You can now, using Mocha and Chai, create a test folder to test out this function. And you'll be doing some of that stuff today if you haven't already. Right? It's part of the flow for today, I believe. Boom. Right? Another very common pattern that hopefully you'll employ for your midterm projects, and you could employ for TinyApp as a stretch, is to separate out your routes. Okay? So what I mean by that is, right now what we have is a whole bunch of routes, like app.get. Let's again assume articles instead of URLs, right? Let's just implement one. Something like this. And then you have potentially the one for articles for a given, like be able to actually see a specific article, not the collection of them. Right? You might have a post to handle submitting a new article. Again, I'm just keeping the actual contents incorrect in here, just to show that these are routes. And if you want to employ REST, whether it's in TinyApp or for your midterm project, you know, you can think about like delete and put for update and so on. Or with TinyApp right now, we just use post. So that's another stretch you could potentially pursue. Or I guess we don't have to say update there, something like this. Right? And then we know that we have these like other routes for, in this case, comments like we defined. So you would have these, if not more, again, right below. And this file is just getting huge now. So what can we do to split this up? Well, we know that we can start thinking about these things as resources, right? There's the articles resource, and then there's the comments resource. Why not split them up into separate files and put those routes into each separate file? First, before I do that, I just want to make sure this works so we can see that this is indeed working. So what I'll do is maybe just run the server. I'm already in the server. So I can just do npm start. Oh no, it's already running actually, but I'll just run it here. Right, port 8080. So now that means that I can go into HTTP localhost 8080 and go into articles. Right. It's a little bit harder to simulate a post from the browser without a form. But are you guys aware of Postman? Was that shown to you in a lecture? So I don't have to introduce Postman, which is nice. We can just use Postman to go do a post to /articles, right? That response comes back. With me so far? So we want to refactor this and put it in its own file. Right? Cool. How am I going to do that? Well, I'm going to take all this stuff, cut, new file, and let's put it in a folder that's not libraries, it's our routes. Just so that's more obvious. So in here, we'll have a routes for articles. I'm going to paste it in there. And of course, we're going to require it here as a result, since it needs to be accessed. So we could do that maybe here. We'll call these article routes, perhaps. If I could only type. Right. And they're coming in from routes / articles. By the way, nothing coming in from Victoria yet. No. Yeah, so that's being required, but something needs to be exported from the other side, right? So I need to module exports that. The problem I'm starting to see, if I even just have this right now, is that this is not going to be what I expect. This is going to fail immediately if it tries to require this file, because there's this app thing that doesn't exist in this file. It was existing in the server file because we had app, which was initialized with Express. Right? So Express actually allows us to use something called Express routing express.router. Right? So we can do something like this. Let's do it with the modern ES6 approach. I don't know why they're still using var here, for example. So in this file articles.js, I'm going to do const router equals or I'll do something like this. I guess I'll just, for now, just take this and we'll refactor that later. But we'll just do const here. And now, instead of app, I'm going to say router dot. Okay. Same idea though. I can still do .get, .post, and all of those things and register these routes on them, but it's a nice like compartment of routes. It's not all the routes, it's just the routes that are specific to a particular resource. And as you might expect, we're going to need to export that. So, having written so much code already, let's not jump to the full solution, but let's at least console log this to see what's going on here. Right? What is this? This will be an object of some sort. But it's not an object we created. We were given this object through this express.router function, and we exported that exact object back. But before exporting it, we added some behavior to that object. Some new routes. So let's go ahead and run that. I know it's nodemon, so it just runs anyway. But we see, here's our router. And it has a bunch of routes defined. They're not very easy or friendly to read, but they're there. Right? And now on the server side, I can use these routes. So I would say, of course, after I've loaded up Express, right here after the middleware. So this is things like body parser and cookie session and things of that nature. After it, maybe I'll say like our app routes, our stuff, right? And we can say app.use again, similar to this. And we'll say, we can give it a path, and then we'll add those routes. Now the path can just be /, right? So we're saying, please add these routes to /. So it'll be / whatever's in there. So for example, we have articles, it'll be / articles. Right? Let's make sure that still works before I go further. I should still be able to, after doing that refactor, still be able to post to new article or get articles. Still works. What's the difference? Code is more organized. based on resources. And I would do the same thing for comments, right? Now, one of the other things I could do differently here is instead of saying mount this to slash, I know that articles are always going to be slash articles slash something, aren't they? Always. So I can say mount this to articles actually, but now it's repetitive such that this won't work anymore. It's saying like can't get, it's giving me back a 404. And that's because my routes are now slash articles slash articles. Because inside the routes, we repeat that. But I could just take the slash articles out of here, right? And just say it's like this, without the word articles mentioned there at all. Let the server.js decide what the prefix is for the route, in this case slash articles, and let this thing not worry about it. I would only change it in one place if I wanted to call it slash posts or slash items or something like that. And now we're going to see it's going to continue to work again. Right? Slash articles is still the thing, but now it's defined only in one place. When I actually take those routes and add it to app using use, right here, I specify which route I want. This forward slash, by the way, is not necessary there. Yeah. Question? Yeah, sure, you can add it, but it's not necessary. Yeah, Express is smart about like making sure that the slashes are, if it's duplicated, it won't add 2 slashes and things like that. Yeah. Yeah. And then you do the same thing again for comments. But maybe for comments, it wouldn't be slash comments. It would be slash articles, slash article ID, like we said, slash comments, and then you would have your comments routes. Now I don't have to repeat that prefix every time because it's going to be everywhere. Agreed? And maybe for upvotes, if they're specifically for comments, it would be app.use comments / comment ID, and it would be comment upvotes routes. Do you see that? And these are just now in separate files. You can do this right now today if you have the extra time as a stretch to organize your URLs versus your users, right? Your URL routes don't need some of the things that your users routes needs in terms of helper functions. So even your dependencies now become cleaner, right? In terms of what you're going to require in this file where you list these routes, or what you're going to require in this file where you create the comment routes. Yep, question? When I use app.use, yeah, so this is the prefix, and then these routes are added after, essentially. So everything has to be slash articles slash whatever's in here. So if this has like slash hello, it'll be slash articles slash hello. Yeah, you essentially give it the path to begin with. Yeah, app.use can be used in different ways though. So in this case, I'm using it like this. It's a little confusing. Like here, you can see there's no path on app.use. So you don't have to specify this. Okay, I want to show you a couple other things. So can we move on from this? Yep. So here's one thing. The other thing I wanted to show you, let's go back to the agenda. Whoops. So we talked about route separation. We remember the secret keys we were talking about? The cookie session key that like makes sure that it's using that as the salt to encrypt the cookie data. Well, you would ideally want to put that into some kind of another file and then git ignore that file because you don't want that checked into source code. A common pattern for this is to use .env files. And if I just search for .env, you know, dot files are usually hidden files in Linux. That's why we're saying dot. And env is like environment variables. Remember process.env in Node from week 1? Process.env, I think we used for, did we use process.env? Oh, we used argv. Sorry, we didn't use process.env, but Node has process.env built in. I'll show you. So there's process.env. Has a whole bunch of, whoa, I probably shouldn't show you this. There's a whole bunch of like environment variables that have that whatever my kind of shell environment has, right? And so I could actually modify those so that when I do access process.env, I could do something like this. Dot cookie, or yeah, cookie secret, right? And it would not be undefined because it would be loaded from some other file, and that file would be git ignored. So .env, we could create that module ourselves, but there's many packages that exist that allow us to do this, and they exist in various different languages. In this case, this is the JavaScript one where we can use again process.env, and we would just have a file in our source code called .env, and it would look. We would just basically require .env and call a function on it. And then we're able to put database credentials, API keys, again, cookie, salt, secrets. If you're using hosting and you're using Amazon services or Google Cloud or whatever, and you have these authorization keys to be able to access those accounts, you're sending emails, so maybe you have an email, a Gmail key or something like that. All of those sensitive things would go into this one env file using this key value pair kind of, one per line. And then you would be able to just say process.env dot whatever key you decided to use in that file. Very easy to use library, right? Very simple. Probably only a few lines of code in the library itself. So it's a very common pattern to create a .env file, to git ignore it, and then to put in our credentials in there. And so they wouldn't be checked into source code. Especially for public repos, right? You guys have stuff that you're submitting onto GitHub, like you're pushing to GitHub, and it's public. You don't want your GitHub key or other things in there in case you ended up, needing it for some API access, right? Any questions about that? No? I want to show you one more thing. Another thing that's kind of missing, we didn't write down at the beginning when we started, is like logging. I find it very hard to debug what's actually happening in terms of when I make a request to the server. So I would suggest, either for TinyApp or at least for your midterm projects, that you use a logging library. What does that mean? When I just search for Express logging, we can see that there's specifically a middleware called Morgan, probably the most popular for Express, that can be used. That's actually part of the Express.js organization, so it's kind of promoted by them or even maintained by them. And Morgan, you say something like const Morgan equals require Morgan, and then you'd be able to use it fairly quickly. So let's just see, do they have... This is just vanilla HTTP for Express. Here we go. So you just use again because it's middleware, right? You do something like this. Let's put it up here, maybe. And then where we have our middleware, we would just add a please use Morgan. And I want the log to look like this. There's different strings we can use here as part of the Morgan library. So we could say tiny, we could say combined, whatever. Let's take a look at what this does. So right now it's giving me an error. Cannot find module Morgan because I have to npm install Morgan. Once that's done, I can require it. And now let's clear the screen and go to make a request. Let's make a request for /articles. Send. We get back a nice, every time there's a request, we get a nice string that tells us a bunch of combined details about that request. Right? For example, if I had question mark ID equals something, It's going to be included there. So I get to see the requests as they come in, which is really nice. So it's great for debugging, and just even on production, when if you were to ever deploy this, you want to be seeing kind of how much traffic you're getting and things like that. Logging is one way to do that. Finally, I know it's 12 o'clock, but I also want to show you another interesting thing about Express in the wild. Now, there's a lot of cool things I can show about Express in the wild to prove that Express is used quite a bit. But there's only one that I kind of want to start with and maybe end with, given the restriction of time. And it is this library that I came across last night when I was just Googling which one would be a nice one to show you guys. And I didn't know about it before, but it's this thing called Hackathon Starter. Lots of stars on GitHub, so it got my attention. And I wasn't Googling for Hackathon Starter. I was Googling for like open source things that use Express. And I came across this. And essentially, it's a boilerplate for Node.js web applications, so that when you go to a hackathon where you want to get shit done quickly, and you just want a lot of like boilerplate starter code that you don't have to write from scratch, this is one example that people tend to use. You could theoretically use this for your file projects if you wanted to build them with Node, right? And the documentation for it is just insane. There's some testimonials or whatever. It gives you a nice like styling right off the bat, so you don't have to make decisions on that. You can just get going with the business logic. Even things like being able to sign in from other sites, because that's something you don't want to be building from scratch. But what does it use? Express, right? Not uncommon to find Express being used for a lot of open source or closed source projects. Now, it also uses MongoDB for the database, so there's additional things. But look at all the packages that kind of come baked in. Some of them you might recognize because we're already making progress, aren't we? The first three, recognizable. Even Chalk we played with a little bit, didn't we, in week 1 for coloring? Right? .env, remember I talked about that just now? Also included. ESLint, we've used, included. Express session is what they use. They don't use cookie session. Low tide or low dash, which we looked at a little bit, is already baked in. Mocha and Chai are already in there. Moment for date time stuff. We'll be looking at Node SAS very soon. Passport is what they use for authentication. If you want to write that down for midterm projects, you could use Passport for OAuth and that kind of stuff. They use request. We played with request before, and so on, right? So there's a lot of stuff kind of built in, not trying to promote this library, but just to use it as an example to show, look, you already know a lot of the stuff that this thing actually uses, right? And one big part of it is Express. Okay, we'll leave it there. If I had more time, I'd go into some other real world kind of examples, but they're not critical for you right at this stage. They're just nice to know, to get excited about this stuff. Before I adjourn, of course, like I said, I'll send the notes, but are there any questions or things that you thought you want me to add in the notes that I wasn't able to cover about stuff like this? Yep, how are you? That's a good question. The question is, if you can use gets and posts for everything, then what's the big advantage for using things like put or patch or delete? There are people that actually don't use those, and they actually build production scale web applications with just get and post. They exist. There are certain behavior differences with post versus put and delete versus post to do with idempotence and safety that you can take advantage of, but I'm not going to go into them today. But I'll just put those keywords in your mind to look up kind of, and they're part of the readings for today and the rest stuff around idempotency and safety that you kind of get like nicely. And then also it's just more maintainable even if you don't care about that stuff, right? Knowing that it's a put tells you that it's an update. Seeing a delete in your network tab tells you that that's a destroy versus a, you know. So it's also just separation and cleanliness. Any other questions? Hopefully this lecture didn't overwhelm you. Like, that wasn't the intent. It's more just kind of inspiration and a lot of review. I ended up doing a lot more review than was originally planned. But again, this lecture is less critical to Tiny Apps, so I figured why not. But let me know in the feedback if you found the review to be too heavy or whatever, so I can adjust for next time. Cool beans? Thank you so much. Bye-bye.